Thanks for the introduction. All right. So yeah, I'm going to be telling you a little bit about the Rust 2018 module system, but to build up to that, I want to give a little bit of history about both myself and how I came to be giving this particular talk and what other types of things I want to be covering with it. So I first got involved with Rust a while before the first RustConf here in Portland 3 years ago. And I gave a talk at that first RustConf called In Order to Form a More Perfect Union, because I've been working on C-style unions for Rust. I got those contributed as part of an RFC so that I could support building virtual machines based on Linux and the dev KVM interface. And this was something I was really excited about. It did eventually get merged and released, and there are now many virtual machines based on Rust, which I'm incredibly excited and enthusiastic about. But that talk was not just about a specific language feature. That talk was also about how we build a more perfect Rust through the RFC system. It was a case study on the RFC process, how we evolve Rust, and how we interact with the Rust community. I love the Rust community. It's incredibly fun, incredibly energizing to work with. It is the most fun open source community I've ever worked with. And as a result of that talk and other work that I'd been doing, I ended up getting involved with the Rust language team and later the Rust cargo team. And from that perspective, I'd like to tell you about the new module system that was developed for the Rust 2018 edition. But as before, that's not the only thing this talk is about. It's really about how the language team works, what the processes are behind the scenes, what it's like to be in the room where it happens. And so I want to go into some more detail about how we iterate on a solution and how, over a couple of years, we managed to develop this module system starting from, I think there's a problem here. So not long after I got involved, there was an effort called the Ergonomics Initiative that was aiming to try to provide further simplicity for the language, as well as a measure of consistency. How can we not just add things to the language, but how do we improve what we have? How do we simplify what we have and make it a lot more usable for people? So in January 2017, we started having some interesting discussions about the module system. One of the members of the language team made a blog post talking about the usability of the module system, what problems they saw. That kicked off a whole bunch of discussion. Many other people made posts and discussions and had offline conversations. And we started discussing, well, what do we use modules for? What purpose should they serve? And how do we want them to work? So I want to give a little bit of overview of how Rust modules work and what style they form, starting with the Rust 2015 module system so that I can contrast that a little bit. So a bit of review for anyone who doesn't already know. In Rust terminology, a module is one organizational unit of code, often but not always corresponding to one source file in Rust. And a crate is a library or a group of modules that is used as a reusable library within the Rust ecosystem. So the other piece of terminology and syntax that I need to introduce, if you haven't seen it before, is that Rust modules can correspond precisely to a file. You can say mod example semicolon, and you will get a module from example.rs. But you can also say mod example and then put curly braces, and you can inline the contents of a module. This is really useful if you're just using them as a local organization tool within a large file. They're also really useful if you're trying to give examples on slides and don't want to say, this is part of this file and this is part of this file. So with that in mind, here's what normal use of some Rust dependencies look like. This is using the command line argument parser clap. In cargo.toml, which is this is the only time I'll be showing this part, you add, I want to use this version of this crate. It will automatically get pulled in by cargo. And then somewhere in your main program or your main library, you can say, I have this external crate named clap, and I want to use potentially this thing in it without having to give the full path to it. And then I could define a function that uses pieces of it. So I could reference clap app, or I can reference just arg after I've said use clap arg. So this is the 2015 module system. And this is how it works when you're in the top level module, main.rs or lib.rs, depending on if you're a program or a library. And most crates start with just one module. They start out building things up from scratch. They do some interesting stuff. They put it in main, they put it in lib, and everything works nice and simple. And the problem is that paths for crates, among many other things, worked differently once you created submodules, which made it harder for people to introduce modularity into their program. They start building something with a single module, they add more modules, and suddenly they run headlong into the brick wall of, I didn't know about this part of the language. So if I define a submodule, say I want to move argument parsing all off to somewhere else in the program, then use looks the same. I still use clap : arg, but the usage, suddenly I have to say : clap : app if I want to reference it. If I leave that out, I get a compile time error saying, well, I don't know what clap is. Even though you can use clap, you can't reference clap. So this was really confusing to a lot of people, and it was especially confusing because you didn't hit it until you introduced submodules. Another problem is that paths for submodules themselves also worked differently in submodules. When you've organized your program, referencing pieces of that program from other pieces of your program works differently depending on where you're doing it from. So let's say I define this module, this small module that defines a few public structures, S1 and S2. I can go use the module : S1, and then I can name S1 anywhere I want. I could use it as the type of arg1, or I can directly name something if I'm only going to reference it once, for example, S2. Now let me move that into a submodule. And I still reference arguments by saying S2 in arg2 here, but notice that I have to say self : S1. By the end of this talk, colon is probably going to stop sounding like an English word, so forgive me in advance for your brain for the following hour. The problem, again, with this is unexpected. You get an error saying, I don't know what M is. You stare at it, you're like, M is that thing I just defined and told you about. You should understand this. So these are the types of inconsistencies that we saw when saying, why does the Rust 2015 module system work the way that it does? And these introduced big surprises when you add modules to an existing one-file project. There were also many other improvements that we wanted to make out of this system, and I'll talk about some of those later. But I also want to take a moment here and say this is, again, not just a talk about how we wanted to fix the module system. This is also a talk about development and consensus processes and how we reached the successful module system. So let's look at the requirements we have so far. First of all, we said you really shouldn't have to say extern crate. It's a little redundant. When you look at that first example, you had define it in cargo.toml, add extern crate, and then use it or reference it. That's 3 places that you have to name it. Well, one of those is actually using it, and one of those is saying where its version is, so those are clearly required. Extern crate just feels redundant in that regard. So we said you shouldn't have to do that. We also said that you should have the same syntax in the top-level module and in submodules. I should say I'm glossing a little bit over the requirements here of these are kind of what we eventually figured out the requirements were. But this is about what we ended up at, that these were the most important things. We wanted the same syntax, whether you were in main.rs or 2 levels down or 3 levels down. So this led to some very extensive discussion in language team meetings many times over. We have regular weekly video calls with all of the members of the language team. We had discussions on the Rust internals forum, which is a discourse instance. We had discussions on Discord, the chat service, and a number of in-person discussions, and pretty much anywhere else we were talking about things. This was one of our top topics to go through. We also debated things like, should you have to reference external crates specially with extern : or should you reference your own crate specially? We were trying to figure out what is the unusual case and what is the common case, and we kept going back and forth because it felt like if we're going to be consistent about paths, one of these would have to be qualified somehow and one of them wouldn't. So this resulted in a series of not 1, not 2, but 3 separate RFCs trying to get this right. The first 2 were closed. The third one had eventually reached an approach that we all had a rough consensus on. So the approach is what we later came to call anchored use paths. We didn't name it at first for much the same reason that Rust 2015 wasn't originally called Rust 2015 until we had to distinguish it from Rust 2018. But we eventually called it anchored use paths. And the idea was that use paths always had to start with something that referenced a crate, either a crate name like clap : or rayon : or your own current crate, in which case they would be crate : or you could still use self if you wanted to use relative names, but you didn't have to. Or you could use super to reference the parent module, which was really common when writing things like mod test, let me pull in things from super in order to test them. So we finally had language team consensus on this RFC 2126 called path clarity. And that's exactly what it was trying to provide, is clear up a bunch of the confusion around how do you reference paths. It was, however, not fully satisfying exactly. It had a fairly mixed community reaction, and there was something about reading through it and dealing with it that felt kind of, okay, this technically meets all the requirements. But so to best sum up what we later realized the issue with it was, I want to use a post that Aaron Turin used to describe the module system as proposed. He said, these situations, meaning dealing with submodules, are particularly bad in Rust 2015 because the code works without self : at the top level module, but not elsewhere. Rust 2018's current design helps by making the code not work anywhere. OK, technically that's a consistency. It also would have required changing most existing Rust code out there to change how it referenced modules. RustFix would have potentially helped with this, and it would have been essential to have that available. But none of us were wildly excited about what felt like it would be the most invasive Rust 2018 change. Please go change all your programs to use this new module system. So around June-ish of 2018, maybe somewhere in those months, Aaron and I had a discussion on Discord that amounted to, OK, this is where we ended up. This is the consensus we had. Could we talk about how we got there and why we couldn't just? It was one of those, like, are we really here? Is this really what we're about to do kinds of conversations, and to look over it. We talked about, well, what are the additional requirements we'd really love to have if we could? And what we said was that the new requirements were, we'd like to have uniform paths between use and between expressions, so that the same path that you can use anywhere in your program to reference a module or a crate, you could always take that path and hoist it up to a use declaration. So if you can write A : B : C, you should always be able to use A : B : C, and then just write C. It's a very nice property when you're used to like IDE refactoring tools and similar. You feel like this name should look the same as this name, and then I just shorten this name. So with that in mind, we also wanted something that was compatible with the majority of Rust 2015 code out there. We said this edition should be an opportunity to have new features and exciting new things and not worry that we are breaking things, but at the same time, we shouldn't gratuitously break everything if we can help it. So the concept here was one of uniform path resolution. The idea was you could check a series of things, and whenever you name an identifier, name a path, you would first check whatever was in the local scope, the whole, well, I just told you what mod im is, then check crates that you have available, and check the prelude, which is where we put things that are automatically in scope that you can always name, like option and result. So here is some Rust 2018 code that uses that as an example. We define those same two structs in a sub-module. We can just use im : S1, and it works. And we can also name im : S2. It's the same syntax whether you're in a use or in an argument. But we can also do the same thing for crates. We can use clap : arg. That still looks for a crate name. In the previous proposal, this would have required potentially naming it explicitly. Or you would have needed something to reference the previous case. One or the other case would have had to have been decorated somehow to be unambiguous. And you can also reference crate names in expressions like this, clap : app. No matter where you are in the program, that will always work if you have clap in use. So this does introduce a kind of search ambiguity. It's effectively saying, well, I'm going to do the right thing when I see a name like clap. Do you have a local variable named clap, or do you have a crate named clap? But it's only ambiguous if a name in scope conflicts with an extern crate name. That's not a situation that comes up that often. It does happen sometimes, but there's a way to disambiguate that. And then in the end, if you have an ambiguous case, I've got the same name for a crate and a module and a variable, then I can disambiguate it. I can still write crate : to reference my own top-level names. I can still use self to reference my own module-level names. Or I can still use just leading : to say, no, really, it's an external crate. So by this time, we had two proposals on the table. We had this solution, which we were calling uniform paths, and we had anchored use paths. So we had some discussion about how those worked. And the biggest thing we found was that there was some reluctance towards a new round of debate on this. We had gone through the better part of a year and a half worth of talking about this, and we had found something where everybody seemed more or less happy with it. It was not exactly satisfying, but it was kind of satisficing. It met all the requirements. And so people were not excited about the idea of, wait, we're talking about this again? On top of that, there was some very reasonable technical considerations with this new proposal that didn't apply to the old one. They amounted to, don't meddle with name resolution, for it is subtle and quick to anger. Everybody who had touched that area of the compiler understood very well that it was very subtle, and when you messed with it, it would mostly work, and then you'd have corner cases after corner cases after corner cases. And so people were very hesitant to adopt a solution that effectively said, well, if we just made the compiler smarter. And finally, there were actually some meaningful differences in the core values and preferences among members of the language team. I don't want to suggest that this was a case of, oh, this solution was obviously better and it just had technical limitations and maybe we didn't want to reopen old wounds. There are meaningful differences here. Not everybody is happy with the idea of, let's figure out in a well-defined order how to handle ambiguity where this might mean this or it might mean that. The thought was, well, the compiler can do that. What if the programmer wants to be able to do that and say, I want to know, looking at a path, what it is unambiguously all the time? And that was a reasonable request. And it was a different request. It was a different set of goals, different set of values, where they were saying, well, why are we optimizing for writing code? Maybe we should be optimizing for reading code. And that's a reasonable statement, and people disagreed on how to implement that. So all that by way of saying, this was one of our, and the language team, one of our first major heavy ideological differences, heavy bits of this is really kind of stressful to debate over, how do we reach a consensus, it seems like we're deadlocked, that kind of thing. There have been others in the past. If anybody wants to look at the history of the question mark operator, there's a long and storied history there. And that one was also heavily like community consensus and whether everybody was in favor of it. But this was one of the first ones where the language team itself was heavily divided and debating and trying to figure out what is the best answer for Rust and the community. So as part of moving forward on this, we first of all tried to make sure, well, can we actually do this? And so I've got credits at the end in detail, but a couple of folks sat down and actually wrote a prototype implementation of this. They said, yes, we can do this. Here's how it works. Try it out. Experiment with it. See how it feels. So there was a successful technical implementation of the new proposal, which then meant, hey, you can sit there on play and play in nightly and figure out what we want it to look like. We went ahead and tried it out on nightly and said, let's see how these implementations work, because the critical point is which one do we choose to stabilize. We looked for feedback from the community. There were several polls, but more importantly, not just numeric and quantitative questions, but more, what do people think? What are other people's values? What are other people's arguments for it? It's not helpful to have 47 people saying they like this and 43 saying they like that. It's extremely helpful to have 4 people say, here's why I prefer this alternative, or here's why my code would look better with this alternative. That kind of thing as more of a qualitative, help me understand what your preferences are. That's the kind of thing that was extremely helpful to see when we were trying to figure out what arguments aren't we seeing, what balance aren't we seeing. Beyond that, we found that we were doing a lot of careful discussion and introspection on what these core values that we had are. That there's an argumentary tactic where you can say, all right, let's step back for a moment. Let's both figure out what our values are that are causing us to get very attached to what our solution is. Let's figure out what the other person's values are well enough that we can explain it back to them, and they're like, yeah, that's what we believe. And if you can't get at least that far, then you're not going to be able to have a good, clear discussion about it. You're just disagreeing. And so we had a lot of very careful conversations like that, where we wrote up documents. We wrote up a Dropbox paper document where everyone wrote separately what their views were, but then went through everyone else's, and we discussed what those were and tried to understand where each other are coming from. And that helped hugely. So in the meantime, we went ahead and released 1.31 and Rust 2018 with a compromise solution. We said, OK, these two are actually very similar, and the main issue they have is when you have ambiguity, one of them would say you must disambiguate it like this, and the other would say here's how we resolve it. So we effectively made that an error and said you can't hit the case where these two systems differ. You have to use something that's compatible with both. And that allowed us to defer a little bit longer figuring out what the correct answer was. It's, again, not wildly satisfying, but it's worth noting that even critically important and very heavy features like this still wait for the next train if they're not ready in time. There is no pass for, oh, you're on the language team, so we'll sneak something in time. We very much said, let's wait a release. We're not ready to make this call yet. So I mentioned we collaboratively wrote a document about both alternatives. We explored down both paths very extensively, had some very excellent discussions where it is incredibly rare to see people genuinely change their mind on something that they felt very strongly about, and it was an impressive sight to see on several counts. So we ended up making the decision shortly thereafter, and we finished up the uniform paths implementation in 132. And that discussion had wrapped up in that form. But it's worth noting that one of the reasons I'm giving this talk is that because it was iterating so quickly, because it was going through all of these decision processes, the final version of this implementation is not exactly what was documented in the original RFC for path clarity. And the new version of what was implemented was effectively defined by the compiler for 132 more so than by written documentation. And then we went back and wrote some more of the documentation later. And so part of the point of this talk was to say, here's how we got there, and here's what we ended up with. So I want to go through a few more of the technical details that I had skipped past earlier to make sure that I would go through all of the decision-making process and values. So with that in mind, some of the other items that we looked at were how to handle macros. This was actually handled through a somewhat separate process and separate RFCs, but it was part of the same unifying theory for a module system. In Rust 2015, there's a whole separate way to export and then use macros. So if you want to use one of these macros like crate name or crate authors from clap, then you use macro use extern crate clap, which will effectively import star from clap if it's a macro. And then all of those macros are just directly in scope, and you use them unqualified. There's no way to qualify them. There's no way to limit which ones you grab. And so this is what you ended up with. This is the only way you can pull in and be modular about macros. In Rust 2018, you can actually use a macro exactly like any other name if you're using it from an external crate. There's some corner cases that I won't go into involving local modules in your own crate, and we're hoping to fix those someday. But in the meantime, you could just use clap : crate name and then use crate name as a macro, just like crate name was any other kind of name. You could also just reference a macro with a scoped name in case you didn't want to pull it in by name, you just wanted to use it where it was. So macro paths now work more or less like function paths. And again, unification and simplification. We added something new to the language, but we did so in a way to make the language as orthogonal as possible so that it worked the same way and you didn't need to learn the rule for functions and then the rule for macros. Just like you didn't have to learn the rule for use statements and then the rule for expressions. A couple other changes. You can now have foo.rs and a submodule foo/bar.rs. You no longer have to write foo/mod.rs. Mod.rs was similar to dunder init.py, if you're familiar with that in Python, or otherwise, this is the module that represents the parent module. Previously, there were some ambiguities here, and you had to always use mod.rs if you had submodules, which meant if you want to add a submodule, you have to move foo.rs. And people also observed that if you had it open in an editor, you'd have a lot of files named mod.rs, and you'd have to see where they were. So this is a little cleanup that is just quality of life improvements. One other item was we started seeing, well, why else are people using extern crate? We wanted to deal with macros, so we needed a way to substitute for macro use. We also needed to deal with crate renaming. People could do extern crate foo as bar and then reference the crate as bar everywhere else. So we ended up with a new feature in Cargo that allowed you to say, hey, I'm using the crate bar, but I'm using the name bar, but it's really the package named foo. So go get the package foo with this version and then name it bar in my program throughout. So this was the replacement for extern crate foo as bar, and that was kind of the last you have to use extern crate, other than if you're using no standard or no core, then there are some cases where you need to reference standard or core with extern crate, but because those are a lot less common, those didn't get addressed quite yet. But this effectively meant most normal programs did not need to use extern crate. So a few other bits of future work that come from the nature of let's pull things out and do the minimal step that we can in order to bypass controversy and avoid bundling 27 different things into an amalgam that will never pass. We talked about what possible future work were a lot of people really don't like having to write mod statements, writing mod example in order to kind of mount example.rs into the namespace. And so there was a lot of discussion that you could implicitly assume mod example whenever you had an example.rs. There are some corner cases here. There are issues like, well, what if I had a local temporary file I was playing with and I don't want it to be compiled, that kind of thing. So this was separated out due to controversy, but there's still interest in revisiting it at some point in the future when there is the appetite to look at the module system again. The other was that you're probably familiar with the pub visibility. This is exported. I'm allowed to use it from outside the module or crate, as well as anything you don't mark as pub is private. The one that people don't often know about is you can write pub parentheses crate, and this is effectively protected. Inside my crate and outside the module, you can use this, but I can't use it outside the crate. So there was a proposal to make this easier to use by defining a new visibility named crate. Rather than pub crate, you could just write crate. You're saying instead of a pub type, this is a crate type. So it had a kind of logical flow to it. It was separated out due primarily to one corner case that we'd seen where it's a little ambiguous and we weren't very satisfied making the call. There were some other reasons as well, but the biggest one was this. If I write a struct, a parenthesized tuple struct, that has crate : T, does that mean the type T that is at the top level of my crate, where crate is a scope, or does that mean a type : T that is named elsewhere that has visibility crate? So this was a delightful little ambiguity that resolving this would have required either defining one or the other to be what happens, or having a rule that says you must disambiguate and we won't allow either one of them. But again, there is still interest in simplifying the use of the pub crate visibility, and so what form that will take in the future, I don't know. So I wanted to take this time to kind of reflect on difficult decisions. This was one of the first major ideological disagreements that we had to work our way through, but there are going to be and have been many more over time. I'm going to very briefly mention async await, for example, where there was a lot of controversy on what the right syntax was. Many, many people said, we definitely need this feature. We need to settle on some syntax for this feature. There were, in fact, almost 3 camps here of people who wanted prefix, people who wanted postfix, and people who want something real soon now, please. And I'm not joking. Those were the 3 camps. And so there was a lot of discussion about this. It did finally get stabilized for 139 very recently, in the last few days, in fact. So that is awesome. I'm so glad to see yesterday people actively using the new async await syntax from Nightly in a training class about async await. So that's incredibly exciting. But again, this is the kind of thing that took a lot of discussion, a lot of very careful working through of, well, what is it about this syntax that you like? What is it about this syntax that you like? Everybody's trying to build a good language. Nobody's trying to sabotage a language. And remembering that and moving forward and saying, how do we get to the best solution, ended up allowing us to reach something that everybody was either thrilled with, happy with, or could otherwise live with moving forward with, without causing any of the problems that people were concerned about with other syntaxes. So I want to sum this up with a few different points. First of all, I would encourage people to beware of satisficing solutions. Cases where, yes, you've technically met all the requirements, you've technically done everything you need to do, but nobody's really happy with it. And so when this happens, sometimes it really is something where you're balancing so many conflicting values you just cannot make everybody happy. At the same time, there was a degree to which the module system was in that state, and then we ended up coming up with a new solution that made the vast majority of people much happier than anything we'd seen yet so far. So a satisficing solution might be a sign that you need to look more closely for other potential avenues. Another is to raise issues very early. No matter how much you declare something as interim or experimental, people will get attached to it. Some people got attached to await bang, the macro-like syntax, and said, oh, I thought that was what we were stabilizing. And the same thing goes for many other cases where once you've gotten something down the path to it looks like this is what I can use in Nightly, then people will get attached to it. Always introspect on what values your opinion is based on. If you have disagreements, then it's worth going one level lower and saying, what is it that makes you attached to this? What is it that makes it important to you? Why do you consider this solution bad? And can you define what bad means? And that includes your own values, which this is a challenging thing to do, to realize, OK, I feel really strongly about this. Why do I feel really strongly about this? Can I explain that to somebody who's not inside my head? Then once you know what those values are, you can turn it, even a disagreement, into a collaboration of saying, all right, let's look at those values. How best can we satisfy those values? Do we all agree what those values are? And can we find a common shared set that we can satisfy all of? And in general, I would encourage people to seek satisfying rather than satisficing solutions wherever even remotely possible. So I want to end with a couple of acknowledgments. Aaron on the language team, formerly on the language team, has been incredibly helpful in formulating a lot of these ideas. He wrote several really good blog posts on consensus and decision making. Eddie B., Kramer, TJ, and Petrochinkov, as well as a host of other people, were critical in making the new module system work, getting it implemented, debugging it, all sorts of other issues, and I am probably forgetting some people, as well as the entire Rust language team, which has been extraordinary to work with, and again, the incredible Rust community. So with that, thank you. I'm available by email and on Twitter, and it's been wonderful talking to you.